We'll continue with conditional statements, and there are actually 4 conditional total statements. Our initial conditional statement, our original conditional statement, is what we call the conditional, and that was if P then Q, right? If the hypothesis, then the conclusion. So we're going to add 3 more. The second one is called the converse. Okay, the converse of a conditional statement is formed by interchanging the hypothesis and the conclusion. So we're going to switch the hypothesis and the conclusion. Literally, you leave the if and the then where they are, and you pick up the hypothesis and the conclusion. You just grab hold of them, and you literally switch places. If Q, then P. You could also say Q, then P. Remember, we said your conditional could be written P, then Q. So the converse can be written Q, then P. So first, let's write this statement as a conditional. Write the following if-then form, and then in if-then form in a conditional, and then write its converse. So an angle that measures 120 degrees is obtuse. So we go in that order. So we'll say if an angle measures 120 degrees. Again, the wording doesn't have to be exactly this, because you may need to add and take away words to make it make sense. But if an angle measures 120 degrees, then it is obtuse. Remember, we try to not put it. We don't want to say if it measures 120 degrees. If what measures 120 degrees? We can put it in the conclusion, but not in the hypothesis. Okay? So if an angle measures 120 degrees, then it is obtuse. That is our P, then Q. So the converse would simply flip that around. So if, and we want to keep, again, we don't want to put if, we would say if it is obtuse, then the angle measures 120 degrees. But let's kind of clean it up so that it makes it sound, but we're going to switch the concepts, right? If an angle is obtuse, then it measures 120 degrees. So you see what I did? I mean, you can literally pick them up and move them. If it is obtuse, then an angle measures 120 degrees. You can pick them up and move them. But when you start a sentence with if it is obtuse, then it doesn't make quite as much sense. And so we want to be clear from the beginning. And so it's better if you kind of rearrange the words, but we're taking that thought of being obtuse and switching it with the thought of measuring 120 degrees. Now, in this case, if an angle measures 120 degrees, then it's obtuse. That is a true statement. So then the converse of that says if an angle is obtuse, then it measures 120 degrees. So the way that we read this is that we read that the hypothesis is the truth. It is happening. So the question is the conclusion true? So if the angle is obtuse, I am saying the angle is obtuse. Is it true then that it will measure 120 degrees? Well, not only 120 degrees, 150 degrees is obtuse too. So I'm stating this as fact. If it's obtuse, it measures 120, like statement of fact. And then you're like, but that's not true. So you give me a counter example. Okay, another C, right? Counter, we've got conditional, we've got converse, we've got counter example. You got to keep all of those straight. They don't have to both be true. So let's look at some truth values. If an if-then statement is false, there's at least one counter example. That's what we talked about. There's a reason to prove. So the statement says if x is equal to 6, then x squared is equal to 36. So I'm saying x is 6. If I square 6, am I going to get anything other than 36? No. So it is true. If x is 6, then x squared has to be 36. The converse would switch those two ideas around. If x squared equals 36, then x is equal to 6. Now I am saying the only way, if x squared is equal to 36, then x has to be 6. And only 6. That's kind of how you read that. Well, you may not think of it, but don't forget we've got x squared is equal to 36. When we take the square root of both sides, let's reach way back into algebra, that's actually plus or minus 6. So my actual, then my converse is false. It isn't true. You're saying that the only answer that can happen is that x is 6, and it's not true. X could be negative 6. Okay, so let's look at our statement here. If two lines are parallel, then they have the same slope. That's true. We'll talk more about that in the next unit. So the converse would be if two lines have the same slope, then they are parallel. Again, we try not to have our sentence starts with a if this, or if it, or if they have the same slope. Who's they? So again, rearrange your words so that it makes sense, but switch your concepts. So if two lines have the same slope, then they are parallel. That's also true. So they can have the same truth value, or they might not have the truth value. Now, here's what happens when they do. When they do have the same truth value, when the converse and the conditional, when they both have the same truth value, you can write what's called a biconditional. Okay, it can only be written when the converse and the conditional are true. We use the words if and only if. Or you can use IFF for short. That stands for if and only if. So let's write a biconditional for that statement because both the statement and the converse were true. So let's write that biconditional. So the biconditional would say then, we go back to our original statement, if two lines are parallel, two lines are parallel. We're writing a biconditional, so you don't start with if. Okay, you state the first, you state the hypothesis. Two lines are parallel, and then you say if and only if. So you say hypothesis, P, if and only if Q. See this statement right here? P, if and only if Q. And that's where I messed up, as I started it as an if-then statement. So two lines are parallel if and only if they have the same slope. And what biconditionals give us is good definitions. That's what they are. Is once you have a biconditional, if your conditional and your converse are true, then you have a good definition. So your conditional, if you want to test and see if you can write a biconditional, you have to test your first statement and determine if it's true. Test your converse and see if it's true. And if they're both true, you can write a biconditional. Now, so we have our conditional and which is if P then Q. We have our converse, which is if Q then P. And then we have our negations. Now, just a thought, negation doesn't mean adding the word not. It means making it the opposite. Okay, so it's kind of like putting a negative sign in front of it. You might have a double negative. If it was already negative, you make it positive. If it was positive, then you make it negative. And so that you got to be careful with. You're not always adding the word not to negate it. You're making it the opposite of what it was before. Now, an inverse negates the hypothesis and the conclusion. So it leaves everything in the same order. So we had if P then Q, that was our original statement. We had our converse was Q then P. So our inverse is if not P, then not Q. We would write that shorthand this way, not P, then not Q. That little tilde means not, or to negate. So if the original conditional says if you have a funny haircut, then people will notice you. The converse, I didn't ask you for that, but the converse would say, if people notice you, then you have a funny haircut. The inverse, you need to negate the hypothesis and negate the conclusion. So if you do not have a funny haircut, then people will not notice you. Okay, so sometimes it is as simple as adding the word not. Sometimes you have to finesse the words, and sometimes if it already says it isn't, then you have to say that it is. That's what negates it. Okay, so we're negating it. We're changing it from being positive or negative in intent. Okay, now one good thing that when we're asking for truth values, your verses, your inverse and your converse will always have the same truth value. Here's why that's important, is I think it is easier to find the truth value of the conditional and the converse. When you start throwing nots in there, it's like, do you not want to go here? And it's like, wait a minute, I don't know how to answer that. Yes, I know I do not want to, and so you're like, you get confused, right? So I think it is easiest to find the truth values of the conditional and the converse. And then if you understand that whatever the truth value of the converse is, that's going to be the truth value of the inverse. So if you're having trouble with the inverse and determining the truth value, then just figure out what the converse is and determine its truth value. Okay, last one, a contrapositive. The contrapositive interchanges, so it does what the converse does, and it negates, it also does what the inverse does. So the converse switches them, the inverse negates them, the contrapositive switches and negates them, okay? If not P, then not Q, or we would say not, if not Q, then not P, excuse me. If not Q, then not P, okay? So having these, knowing those is very helpful. Okay, so the conditional, the original statement, if P then Q, if Monique finds another job, finds a summer job, then she will buy a car. The contrapositive would say, then, so we need to switch it and negate it. So that means we need to talk about the buying a car first, but we need to say she's not going to buy a car. So if Monique, and we'll have to play with these words to make it make sense, will not buy a car, then, and now we need to take the hypothesis and negate it, she will not find a summer job. Now, here's another good thing. We've got lots of knots flying around now, and it makes it really hard. But if the conditional is true, then the contrapositive is true. Okay, so the verses, the inverse and the converse, they have the same truth value, and the conditional and the contrapositive, they have the same truth value. So these two have the same truth value, and these two have the same truth value. They go together, okay? Your conditional and your contrapositive, and then your two verses, your inverse and your converse, have the same truth values. Okay, so there are a lot of C words: counterexample, conditional, converse, contrapositive. Okay, make sure that you can keep up with what stands for what.